An important learning outcome of this chapter is to learn how to use a set of equations known as the kinematics equation. You also require to know how to derive them. The equations allow you to calculate certain parameters of a motion such as the displacement, initial velocity, final velocity, acceleration, and time taken. The equations are also sometimes known as SUVAT equations. The kinematics equations are valid for constant acceleration cases only. As you will see later on, how the equations are derived for an object that moves under constant acceleration. Consider an object that moves from an initial velocity u to a final velocity v with constant acceleration a in a time of t. This is the velocity time graph for that motion. Looking at the gradient of the velocity time graph, the gradient of the velocity time graph is constant. Therefore, acceleration is constant too. Since acceleration is equal to the gradient of the graph, acceleration is therefore equal to v minus u divided by t. Rearranging the equation, we would have v equals to u plus at. This is the first kinematics equation. Next, the area under a velocity time graph is equal to the displacement. So if displacement is equal to the area under the velocity time graph, and the area is the area of a trapezium, the displacement is therefore equal to half u plus vt. This is the second kinematics equation. The remaining equations are obtained by subbing the first equation into the second equation. For example, if we were to sub in for v, where we know that v is equal to u plus at, we would get s equals to half 2u plus at times t. The resulting equation would therefore be s equals to ut plus half at squared. This is the third equation. Then, subbing for t, v is equals to u plus at. T is equals to v minus u divided by a. Subbing this into equation 2, we would get s equals to v plus u divided by 2 multiplied with v minus u divided by a. Notice that v plus u multiplied with v minus u is actually the same form as a plus b multiplied with a minus b. We learned in maths that this can be simplified to a squared minus b squared. So over here, we can say that v plus u multiplied with v minus u is the same as b squared minus u squared. So s is equals to v squared minus u squared divided by 2a. Simplifying the equation, we now have v squared equals to u squared plus 2as. This is the fourth equation. For the last equation, we will be subbing for u. Since v is equals to u plus at, we know that u is going to be equals to v minus at. Subbing this into equation 2, we get s equals to half v minus at plus v times t. S equals to half 2v minus at times t. Eventually, the equation simplifies to s equals to vt minus half at squared. This is the last equation. It should be clear by now that all these equations are derived from the same graph, where the acceleration is constant. Therefore, the kinematics equation can only be used for motion where the acceleration is constant. It should never be used for cases where the acceleration is not constant. Last but not least, to do all your kinematics question, you really only need to know the first four equations. The fifth equation is something that is rarely asked. It's only been asked once or twice in the MCQ questions.